Lesson 27, Line Plots. Display data on a line plot. Study the example problem showing how to display data on a line plot, then solve problems 1 through 6. Example: Jenny measured the heights of tomato seedlings in her garden. The heights are shown in the table below. Make a line plot to represent the data. So we've got seedling heights. And these are the seedlings. There's A, B, C, D, E, F, and G. And the height of each seedling is underneath it in inches. A is 1 1/4 inches, B 3/4 of an inch, C 1 1/4 inches, D 2 inches, E 1 3/4 of an inch, F 1 1/2 inches, G 1/2 of an inch. Use a number line with a scale of 1/4 of an inch. The scale means each tick mark is counting by whatever the scale is. In this case, it's 1/4, so each mark is going up by 1/4. Notice it goes from 1/4 to 1/2. Remember, that's because 2/4, if we were to count up by another fourth, 1/4, 2/4, 3/4. Remember, 2/4 simplified is the same as 1/2, so that's why that looks a little different. It says for each seedling, put an X on the line plot above its height. So A was 1 1/4, and there's an X mark here for A. B was 3/4. Here's an X for B. C was 1 1/4. There's an X for C. D was 2. E was 1 3/4. F 1 1/2. G 1/2. So there's just an X above the measurement or the height for each of the seedlings. For problems 1 through 3, use the line plot in the example above. It says explain how to use the line plot to find how many seedlings Jenny measured. So remember that each X on the line plot represents a seedling. You could also look at this table and see how many seedlings were planted, but remember each of these seedlings and their letter are represented with an X on the line plot. So to figure out how many she planted, you could count the X's on the line plot. So we have 1, 2, 3, 4, 5, 6, and 7. So the answer here is 7 seedlings, and you would explain in your own words what we just did. Number 2, what are the heights of the shortest seedling and the tallest seedling? Explain how you know. So this is where it gets a little confusing sometimes, because a lot of people want to look at the shortest height on the line plot and say that's the shortest seedling, but there is no seedling above 1/4 of an inch, which means there is no seedling that is that short. So we wouldn't say the shortest one is 1/4 of an inch because there is no seedling that's that height. The shortest seedling would be represented by this X here, which is at 1/2 of an inch, because it's the first X that's closest to the smaller end or the lower end of the line plot. So the shortest one is over 1/2. The shortest seedling is 1/2 of an inch. And then the tallest seedling would be at the other end, and in this case, that's at 2. So this marks the tallest seedling, which is 2 inches. And to explain how you know, you would explain what we just talked about, how the smallest seedling was over the 1/2 inch mark, and 1/4 is not the smallest or shortest because there are no seedlings that height. Number 3 says 2 seedlings have the same height. What is the height? And explain how you know. So what you're looking for is which measurement on the line plot has 2 X's on that measurement, because there's 2 seedlings that are both the same height. And in this case, it's this seedling here, A and C, which are at 1 1/4 of an inch. So this is the measurement that has, or the height that has 2 seedlings that are the same. So 1 1/4 of an inch, and then you would explain what we just discussed. Number 4, the lengths of snakes at a zoo are shown in the table below. So we've got snake A through H, and the snake's length is underneath each of the snake letters, and it's measured in inches. Complete the line plot below to represent the data in the table. Lengths of snakes. So remember in that example earlier, we talked about the scale of the line plot, and it said to use a scale of 1/4 of an inch. So it went from 0, 1/4, 1/2, 3/4, 1. 1 1/4, 1 1/2, 3/4, 1 3/4, 2. So this line plot is similar to that one because if you notice, it goes from 1/4 to 1/2, and then the next two that are side by side that we can see are 1/2, or 8 1/2, 8 3/4, and then 9. So think about going from 8 3/4 to 9, how far that would be. That would just be 1 more fourth, because if you've got 3/4 here, 1 more fourth would make that 4/4, which we know is 1 whole, and the 8 wholes give us 9. Again, if you want to look at it from this point to this point, we said we've got 7 1/4. The next one would, if we're counting by fourths, would be 7 2/4. But remember what we talked about earlier, that 2/4 is equal to 1/2, or it's the same fraction. They're equivalent, we could say. So with those two ways, we can determine that this number line, or this line plot, is going up by 1/4 of an inch each time. So if this point is 7 1/4, we're going to go backwards 1/4, or go down or decrease 1/4. So if we've got 7 1/4, 1/4 less than that would just be 7 wholes. So that would make 7 wholes, 7 1/4, 7 2/4, which we know is 1/2. So 1/4, 2/4, that would make this be 7 3/4. Then 8 wholes, and after 8 wholes we add another 1/4. So 8 1/4. Then we've got 8 2/4, which is really 8 1/2. 8 3/4, and then 9. Number 5 says, look at the line plot in problem 4. How many snakes are less than 8 inches long, and explain how you know. Oh, I completely forgot to complete the line plot. I'm sorry, please forgive me. Okay, let's add our X's to the line plot. Let's see, we'll start with A. Snake A was 9 inches long, so we'll put 1 mark over 9. B was 7 1/4 inches, so we'll find that on the line plot and mark an X. C, 8 1/4 inches. D, 7 1/4, so we'll put an X on top of the one that's already there. E, 8 inches. F, 7 inches. G, 7 3/4 of an inch. And H, 8 1/4 of an inch. Okay, I'm gonna double check. 1 2 3 4 5 6 7 8, and 1 2 3 4 5 6 7 8. Okay, they're all there. All right, now we can go to number 5. So it said, how many snakes are less than 8 inches long, and explain how you know. So this mark here is exactly 8 inches, and there is a snake that's 8 inches long. But if you notice, the question doesn't say 8 inches and less, it just says less than 8 inches. So we can't count this one that's at 8 because that's not less than 8. Anything on the other side of this line, on the smaller side of that line, would be less than 8 inches. So we've got one snake here that's less than 8, 2, 3, and 4. So 4 snakes are less than 8 inches long. and you would explain that process that we just went through. Number 6, Sally measured the width of seashells she collected. The table below shows the data. Seashell width. So width is how wide the seashell is. You've got seashells A through H, and then the width in inches. So here's how wide each of them were. We need to draw a line plot to represent the data in the table. So if you look at the data in the table, I want to find the smallest number because that's going to help me decide where this line plot needs to begin. I see 3/4, which is less than 1 whole. I see 1/2, 1/4, and 3/4. So it looks like the smallest one here is 1/4. I could start my line plot at 1/4. I could start it at 0. It really just depends on which one you would rather do. I'm going to start at 1/4. And then again, since these are counting, or most of them are in fourths, I'm going to have my scale for this line plot be in fourths. But remember, instead of saying 1/4, 2/4, we're going to write 1/2 instead of 2/4. So 1/4, 1/2. Next would be 3/4, and then 1 whole. 1 and 1/4, 1 and 2/4, but really that's 1/2. 1 and 3/4, and then the whole number 2. Now let's see if there's anything larger than 2 where I would need to extend this line plot. It looks like 2 is the largest width. So I think we're good. All right, so seashell A was 2 inches wide, so we'll put an X above 2 inches for that one. I'm going to mark these as I go so I don't skip any. B is 3/4, so we'll put a mark over 3/4. C is 1 and 3/4. D is 1/2. E, 1 and 1/4. F is 1/4. G is 3/4. And H is 1 and 3/4. So let's double check. Let's count how many seashells there are on the table, and then we'll count our X's to see if it matches. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8.